Hey everybody, Alex at BP Autosports here, and I know it's been a little while, but we're back today with a pretty interesting project. So I'll spin the camera around, and we can see this. And this is the side-by-side blog guys Jurassic Park RZR. So now, I guess we affectionately referred to it as the 2JP RZR because of this little detail right here. Now what these madmen have done is taken this 4-seat RZR, eliminated the rear seats, and have stuffed a 2JZ GTE in there. Out back here, can't see it right now, it isn't in there, but there will be a Power Glide and a Ford 9-inch back here. And what we're doing is taking this nice little Precision 7275, these wastegates, this blow-off valve, clamps, flanges, etc. And we're going to make an exhaust manifold and maybe some induction tubing for it. Now, if you saw in their video, after some discussion, what we opted to do is to build a 321 stainless exhaust manifold for this application. The turbine flange on their turbo is a V-band unit, so we'll have to make a circular 6-into-1 merge collector for it. And that circular merge collector is what this video will focus on. So we'll go over and take a look at the materials that we'll use for this. And I'm sorry if you hear a little bit of noise, the heater is running up top over my head there. Here we have assorted stubs of 1.25" Schedule 5 321 stainless pipe. So this video will take this pipe, put it into this bandsaw with this red collector jig here, and by the end of the video we'll have a fully welded finished merge collector ready to become the part of an exhaust manifold. And we'll go over some of the basics of the geometry involved with building a merge collector, how to cut them, welding them together, the process I use for them, prep, the whole 9 yards for building one of these things. So I guess let's get started on it now. Now, my merge collector cutting fixture requires roughly 24 inches of pipe to properly reference and cut merge collector pieces. So you can see some of these pieces here obviously are not 24 inches. So what we're going to do is to take these smaller sections here, tack them to these little bit longer sections here to give us the length that we're looking for to cut these things properly. And now we have our 3 sections of pipe, which you can obviously get 2 merge collector pieces off of each of them to equate to 6 total for our 6-into-1 circular collector. So the next step is to take the cutting fixture, which obviously is not the prettiest thing in the world. I made this a number of years ago and it has cut hundreds of merge collectors, and we bolt it down to the bandsaw. I have 2 threaded holes that go into the bed or the base of the bandsaw that bolt this collector fixture down. And the one neat thing about the way that I designed this is if you align the holes, it's hard to see, but the rear hole is aligned. This serves as the pivot bolt, and right here you can see it's actually a multi-position collector fixture. So looking down from the top, you can see what I refer to as the splay angle of the collector cutting fixture. So let me take and thread this bolt into the back here a little bit, and I'll show you how this splay angle affects the merge collector. I guess we'll throw the front bolt in as well so it's actually guided correctly. Alright, so we have those bolts threaded in, and the way that it's set up now is the most narrow and most tall way that it can cut merge collector pieces. So as you alter this, see that little angle right there takes it and kicks it farther out. And what you're effectively doing is you're taking and narrowing or widening the angle of the V, and therefore affecting how exhaust gases going into the merge collector either collide or merge and flow up into the turbine housing effectively. So on this particular collector, I'm going to make it as tall and as narrow of a splay angle as I can. And the reason I'm doing this is, like I said, to force more of the exhaust gas and the exhaust gas energy actually into the turbine housing and use that energy to spin the turbine wheel as opposed to colliding. Now, the reason that you'll alter the splay angle from time to time is to contend with spatial restrictions or spatial limitations on a particular vehicle or a particular setup that you're building with. And since we don't have really any spatial limitations with this Razor project, we can get away with a taller merge collector that forces more of that energy at the turbine wheel. I have my first piece of pipe put in the collector fixture right now. Like I said, not the prettiest thing in the world, but it does work. The way that it works, I have a piece of 2-inch schedule pipe, which that will allow both 1¼ and 1.5 schedule pipe to pass through. Can't really see it, but down here on the bottom I have 2 little dabs of filler rod that help to align the pipe, and that's on both sides of this 2-inch schedule pipe. And there's a set bolt that goes down through the top to keep it from rotating as the bandsaw blade drops through. On the back side, I have this angle level that I use to determine the rotation between cuts. Now, I always start at 0 degrees. That'll be my index cut, and then I'll rotate the piece to the desired angle to allow me to create a merge collector piece that will go into whatever shape I need. So with this being a circular 6-into-1, the angle of rotation is 120 degrees. And different style merge collectors will require different degrees of rotation between cuts. Something like this 6-into-1 rectangular collector here requires a 90-degree rotation in between cuts. Now you can do the math to figure out the correct degree of rotation to make assorted merge collectors, but you can also do it by experimenting with plastic PVC schedule pipe, as it is the same dimensions as regular stainless schedule pipe that you typically use in a merge collector. This PVC pipe is cheap and it doesn't put any undue stress on your bandsaw, your belt sander, or any of the other tools that you'll use to build one of these. And with some common sense, logic, and a bit of research, you can figure out how to cut virtually any style merge collector that you may need to. So I'll shut up now and we'll start cutting these merge collector pieces. And there we have the first cut of this particular merge collector. So, pull my little squiggle off there. What we'll do now is go back, put our angle level on, check and see that it is still on 0. And from here, I can loosen the set bolt, like so. You don't need to over loosen it, just enough so you can rotate the pipe. Let me see if I can do this with one hand. And we'll take and rotate over, keep going to 120. Now, with my bandsaw and this fixture, just the way that everything works together, there is a plus 5-degree discrepancy off of the base angle of rotation. So what I mean by that is rather than cutting exactly at 120, I go to 125. And I figured out over time in using this tool that that plus 5-degree discrepancy does create a collector that fits together properly. If I would cut it at 120, the collector would be too narrow, or the cuts wouldn't line up properly, and I'd have a bunch of gaps to fill, not exactly the most desirable thing. Now that we have our rotation set, the other thing to keep in mind and to pay attention to is the length of feed out of the end of the merge collector cutting fixture to the end of the pipe. If you have a discrepancy between the length of feed, the collector pieces, the collector cuts, won't be at the same depth on the piece of pipe that you're cutting. So I'll go through a system of checks and balances as I am rotating these and getting them prepared for the second cut. I will rotate, I will check my length of feed, adjust length of feed if necessary, hand tighten the set bolt, double check my degree of rotation, double check the length of feed, and if all of those things check out, then I am ready to tighten down, start the saw, drop the beam, and make the second cut. Now we can see that I have my angle set at 125 degrees. I have double checked my length of feed. I have double checked my degree of rotation, and I have also tightened down the set bolt. So now we are ready for the next cut. So in respect to keeping this video as short and to the point as I possibly can, I'll go ahead and get the rest of these collector pieces cut, and I'll catch back up with you guys in a little bit. Just heard the last bang, which signifies that the final piece has now been parted, and we have our 6 collector pieces. So, I think it's time for me to go get some lunch, and when I get back from lunch, we'll go through, prep those pieces, and then it'll be time to start welding. I'll show you guys exactly what I'm doing here on the belt sander. So this piece right here is one that has not been deburred or prepped at all yet. So you can see on this side here, it has all this metal overhanging on it. On the mating side of it, same thing. And it also has these ridges right above my thumb there, and right above my thumb on this side. So it goes from a piece like this that's raw right off the bandsaw to a piece like this. You can see I've taken the ridges down on either side of it, and I have put a nice bevel around the mating side or the inlet side of it. And the reason that we bevel these is you can see the thickness of the material here, and it's very difficult, if not impossible, to get through the piece when you're welding it to achieve full penetration. So when you put a bevel like this on it, you're reducing the thickness of the material from that to this small little section with a land on the top right where my index finger is here. Now obviously this piece still needs to be deburred quite a bit. You can see on the inside there all the burrs hanging over that would end up on your turbine wheel or somewhere where they shouldn't be. So this step here is just to get it beveled and roughly cleaned up, and then I'll go in with a carbide burr to clean up the rest of the burrs and to get it ready to adjust the surface finish and weld. So I'll go ahead and I'll clean up this final piece here, and then we'll be ready to deburr to prep the surface finish, and then it'll be weld time. All right, let's talk a little bit about the tool used for deburring before I actually go over and start doing it. I like to use this simple, well-worn, double-cut carbide burr. Now, the reason for this is it is a light cut, so you're not taking a ton of material off. You're mainly just removing the burrs, and you have good control over it at the same time. So I'll take this burr, and we'll take the collector pieces, which are now all prepped on the belt sander and ready for final internal deburring. Go do that and move on from there. We have now all of our deburred collector pieces. So this is what they look like now. You see no more burrs, no more overhangs, no more burrs on the inlet side. And you may have just a few of them coming up to the point in the center of the collector, but that is not a big deal as it will be getting welded on the inside, and all those little pieces will get melted and become part of the internal weld puddle and seam. So we'll now take these pieces and they will go on my fancy mystery wheel here that will put a nice polished or semi-polished surface finish on them. And from there, they go over to the welding bench to get tacked together and welded. So I'll go ahead and I'll prep the surface finish. And from there, I will meet you guys over at the welding table. Here we have our 6 pieces. They are all obviously cut, sanded, beveled, deburred, and polished. You can see the nice shiny surface finish on them. So now what it is time to do is to take these 6 pieces, tack them all together, and get prepared to weld. So we'll go to a time lapse now of fitting these up, and I'll check in with you guys after we have a tacked together collector. And now we have one nice 6-into-1 circular merge collector. You can see on the inside, coming to a nice point. No substantial gaps. No anything stupid that would make it a pain to weld. And I also did put on each one of the long straight welds here, there's a bevel on all of those to allow me to get penetration on those weld seams as well. So now the next step is to go ahead and weld it. So we'll go back to another time lapse of that. So the collector is cooled now. It's off the fan. It's sitting right here on the table. Let's take a look at it. Now, this thing came out pretty nicely. You can see the welds on the outside. You can see down on the inside. And let's see. My light will cooperate. I guess not. But you can see there a little bit of the penetration on the inside. See if I can get a better angle. Maybe that'll work. You can see the full penetration welds, and the seams that are visible here, I guess, on the inside of it. So, from here, the collector obviously isn't completely done yet, But we have our good base to start with. We'll go over here to the 2JP and take a look, rough idea of how this is going to sit. Maybe something like that. Maybe kick down a little bit more. Not exactly sure yet. We'll see once I can get the turbo hung in here and play around with some ideas. And either way, it will have some bit of a 2.5-inch schedule pipe elbow on it going up to the turbine flange. But that will have to wait until the next video. Next one will be hanging the turbo, finishing this merge collector up, and moving forward with this project. The rest of this project is very exciting. I mean, for all intents and purposes, it is a 2JZ powered dune buggy that will make 1,000 horsepower, if not more. And if you want to see this collector become part of an exhaust manifold, and to see the other cool things that we have planned for this project, be sure to subscribe, leave a like, leave a comment, and I guess we'll see you guys next time. Later.